look at how we can write an equation for the graph of the logarithmic function. The first thing we want to do is pick out some key features from this graph. So thinking about what we know about our toolkit functions, our basic log functions, normally we would have a vertical asymptote at x equals 0, our y-axis, and then we would have, if it's a log base 10, we would have our horizontal intercept, our x-intercept at the point 1, 0. So let's look for some features that have changed. So we see on this graph, we have a vertical asymptote at the line x equals -2. So this is telling us that our graph has shifted over 2 units to the left. I'm also going to look for a couple of key points that I can use here on my graph. I'm going to use the points -1, 1, and 2, -1. So I'm just looking for 2 nice integer points that I can work with. So I'm going to use the points -1, 1, and 2, -1. So as we start to set up the basic formula for our function, we've got our f of x. It could have some leading coefficient, so I'm going to just call that a for now. I'm going to write this as a log base 10, and then we'll look at the end a couple different ways that we could write this. Because I have shifted 2 units to the left, I'm going to write this as an x plus 2. So that plus 2 on the inside, this shift to the left 2 units is giving us that x plus 2. And then at the end, I'm going to put just plus k, I'm going to call it for now, to mean that there could be some kind of vertical shift as well. And so we'll look at finding that. So first, I'm going to take my point and plug in to my function. So I'm going to evaluate my function at f of -1. So everywhere I see an x, I'm going to replace that with a -1. So log of -1 plus 2 plus k, my point tells me this should be equal to 1. So I have a times the log of 1 plus k is equal to 1. Well, the log of 1, think about what this is saying. This is log base 10 of 1. So think about 10 to what power is equal to 1? Well, it's 10 to the 0 power that is equal to 1. So we have a times 0 plus k is equal to 1. Well, a times 0 is just 0, so this tells us that k is equal to 1. So if we update our function, what we have so far is that f of x is equal to a times the log of x plus 2. Now I know it's plus 1. So there's been a vertical shift up 1 unit. Now let's repeat that same process. Now I'm going to plug in the point +2, -1. So I'm going to evaluate my function at f of 2. So a times the log of 2 plus 2 plus 1 needs to be equal to -1. So I have a times the log of 4 plus 1 equals -1. So we're solving here for a. So subtracting 1, I have a times the log of 4 is equal to -2. Log of 4 is not a nice number. If you put that into your calculator, you'll see that it's a decimal. So I'm going to just leave that exact as log of 4. So to divide both sides by log of 4, solving for a, we get that a is equal to -2 all over the log of 4. So we found our plus 2 from the shifting left using our vertical asymptote. We plugged in 1 point and found k. We plugged in a second point now and found a. So putting these together, now we can write our function. So here's what we have found so far. So if we were to plug in both of these values, our k and our a, our function would become f of x is equal to -2 over the log of 4 times the log of x plus 2 plus 1. And so this is an exact representation of our function. If we were to graph this, it would match that given graph exactly. There is another way that we can write this. If you take a look at these two expressions, both of these are a log with a base of 10. So if you remember from a previous section, we had what was called our change of base formula, which the idea was if you had some log with a base of a of some argument b, that we could rewrite this using a base of our choosing. So we could pick some base and take the original argument on top and then the original base on the bottom. So usually when we're using the change of base, we would choose something like a base 10 or a base e. We use it as a way to put something into our calculator. Well, in those highlighted expressions, we have two logs with a base of 10, so we can kind of use the change of base rule in reverse and combine these together to one single log. Since they currently both have a base of 10, the one that's on the bottom is going to become our new base. So we could write this as f of x equals -2 times, this would become log base 4 of x plus 2 plus 1. So kind of compare that to our change of base, see how we went backwards through that process and took our two separate logs with a base of 10 and combined them together using that argument from the denominator of 4 as our new base when we combine them together. So another way to represent the equation for this graph that we were given is -2 times log base 4 of x plus 2 plus 1. These are equivalent expressions, meaning that they have the same value, just different ways of writing them. Both of them represent this graph that we were given.